Good afternoon, ladies and gentlemen. My name is Mike Hawes. I'm the Chief Exec of the Society of Motor Manufacturers and Traders. You may not have heard of that. We're the complete opposite to a startup. We've been around for 117 years. Basically, we look after the interests of the automotive industry in the UK. That includes automotive manufacturing, imports, supply chain, aftermarket, not just for cars, bus, truck, coach, taxi, trailers, the whole gamut. And increasingly, one of the reasons we've probably survived for 117 years, trying to respond to different changes in the industry. And obviously those changes are coming thick and fast at the moment, especially in the area of connectivity and autonomy. With that, especially around connectivity, it opens up some vulnerabilities. And that's really the purpose of the next session for the next half an hour or so, looking at the vulnerabilities there, what can be done to minimize the risk, prevent them, what is the elements of collaboration. We have a very distinguished panel before you for the next half hour or so. So I'll just get each of them to introduce themselves, just about who they are, where they're from, and really what their initial perspective is on this issue. So, Moshe first.
My name is Moshe. I'm the co-founder and CEO of GuardKnox. GuardKnox is developing and providing cybersecurity solutions for the automotive market. We're all coming from the Israeli Air Force, where our team had provided solutions to the Israeli Air Force platforms and missile defense systems, and we're adopting the methodology that protects those moving platforms into automotive.
Thank you.
I'm also from the Air Force. Hi, I'm Hila from the Israeli Ministry of Transport. I'm in charge of developing the infrastructures, and our main issue is how we keep them safe when we're going to have very big systems and very complex systems to get the traffic, to manage the traffic and manage the trains and the light rails. And that's what my problem is.
Hello, I'm André. I'm the Vice President for Cybersecurity and Functional Safety for Lear Corporation. I'm responsible for protecting our products against all kinds of security issues and functional safety issues. And so I'm naturally interested in everything that makes our products more secure, but also that allows our products to make the vehicle more secure.
So I think that we have a solution for you, so we can discuss it later on. Hello, my name is Zohar. I'm co-founder and CEO at Aurora Labs. What we develop is a self-healing software for connected cars. In practice, what does it mean? It means that we provide a solution that is an in-vehicle software management that takes care of the entire life cycle of the software on a vehicle, like, for an example, detect malfunction software and then to take action about it, like roll back into a safe point, and then closing the loop with a very cost-effective delta over their update, updating only the change between the software versions. And this is how we call it in-vehicle software management system.
Kevin.
Yeah, hi, I'm Kevin Walker. I'm the Chief Product and Information Security Officer at APTIV. And like André, we're a Tier 1. And frankly, I'm new to the auto industry, which is kind of refreshing. Learning new things, but also we're bringing in decades of experience in cybersecurity to the industry. As the vehicles are changing from ECUs to smart controllers to cloud and the like, we need to rethink how we're approaching the problem. You know, we're not addressing 1990 vehicles any longer. And I think the cyber piece in particular is one of his most interest to a lot of practitioners. You know, folks coming out of college with a cyber experience can have their choice where they want to go. How do we attract them to the auto industry is a piece of the work that we're doing as well.
Okay, so I think the obvious place to start on this subject is, we talked before about the vehicles becoming increasingly connected to other vehicles, to infrastructure, to the Internet of Things. Where do you think the biggest single risk comes from? Is it just all that open vulnerability, or is it a particular aspect? Where do you think that biggest risk comes from? Anybody want to go first? Hila.
Yes, I can say as as a state, our biggest concern is that the vehicle, there is a lot of players in the industry which take care of the vehicle, and the vehicles will be safe. You can say that, but when we managing the system, and we want to add, let's say, a small component for the smart traffic light, this component can be the way to ruin all the system. And our big concern is how we make it safe, how we can take a little startup which has a small component, which is very important to us, or can do a very good stuff with managing the traffic, how we make him safe, and how we can be sure that it will not ring all the other systems. And this problem doesn't have a lot of solvers. Not a lot of companies deals with that problem.
Yeah, so along the same lines, I think it's actually dangerous to, try to point it to, there's this one biggest risk, and then only to go for that part. So, Lear provides telematics units for connectivity where it's a no-brainer. They need to be very secure. We also do lots and lots of seat modules where you initially think, well, why would you care about security? Well, it turns out a seat module has 500,000 lines of software code. And if you can hack into it, you can do things that you do not want to happen, like move the driver away from the steering wheel, push the seat up, things like that. So I think it's far better in doing a proper risk assessment, identify what are the actual risks, and then to mitigate, rather than be sort of, preoccupied, I only care about this one area.
I try to boil things down simply. I'm a mathematician, so I have to think very simply. And so when I talk to my team, my peers, and sometimes my customers, there are two C's, complexity and complacency. The complexity will kill us. When I was paid to break into systems, it was the complexity that allowed me to get in. You may have had each module highly secure, but they didn't work well together. There was a gap. There was something missing. We have untold layers within the ability to deliver a car, not even autonomously, just basically even the fleets today. All we need as an attacker is a weakness. So, Hila, I agree with you. I support your position that the state will support us. But I'm telling you, it's going to be hard, right? So we need to be really, really constantly aware of complexity, and therefore become complacent as well. So there is one of the things I'd like to see more of are attackers from all, white hat hackers, or even gray hat hackers from all aspects to test us, because we cannot be perfect. It's impossible.
So if it is impossible, Moshe, do you have some of the answers?
Yeah, sure. First, I think that the best car and the safest car, or the secured car, is Model T, because it's not connected.
And not fast.
Yeah. Who cares about speed when it's not connected, okay? But when we're talking about connected cars nowadays, there are hundreds of attack surfaces, and the GPS was hacked, the radio was hacked, every other connection that is transmitting inside and outside through a car was already hacked. So even the fact that given the fact that the car is connected, we have risks. Now, comparing to a computer, when our desktop is hacked, we might lose our data, we might lose our business continuity, but here, the car is the smallest area in the world where all our loved ones are gathered. That's the issue. Now, OEMs have been manufacturing vehicles for more than 100 years of safe vehicles eventually, okay? But now it's a paradigm shift. All of a sudden, the car has become a 19-inch rack with a lot of computers on wheels. And if we're not looking at a car as a system, not only a single ECU should be protected, the entire vehicle should be secured. Now, on top of it, companies are looking at over-the-air updates. That's another risk. Now, if I'm, as a hacker, are penetrating the OEM data center and sending rightfully a malware to the vehicle, that's another attack surface. So the system approach, this is the one that should be ruled. And I don't think that any regulator eventually will save us from providing secured and safe products. If we're not going to do that, no one is going to do that.
That raises an interesting question, because obviously we have 2 tier 1 suppliers here, other companies, and obviously government, who have involved the business to meet some of these risks. Do you think the OEM, the manufacturers, are doing enough, or to a certain extent your business model depends on the fact that they can't mitigate every single risk? Do you think, what is your perception of them, recognizing you're a tier 1 supplier? You need to be very careful about your customer and what you say about them. But Zohar, for instance, I mean, obviously your business just developed.
I will take the risk. First, I don't think that there is a difference between OEM and tier 1 and startups and other companies like Microsoft and others. Once we develop a product, we are going to have risks. We are going to have challenges. We are going to have software bugs, cybersecurity, wrong parameters, management of the software. There is a lot of lines of code in each product. In a regular vehicle, there is 100 and millions lines of code. It's a great complexity. This is it. Now, the question is, do we have enough time and money to invest to look for the entire risk that we have in a vehicle? So I think that, and maybe a little bit back to your question, a previous question, it's all matter how much energy and budget we are going to put in these areas. And I think that the regulation and the trust that we want to gain from our users, we want happy users. So now the question, how can we balance between our efforts and investments time with happy users?
So maybe I can add a bit from the tier 1 perspective. What I saw in the last 5 years is really a huge step forward. You know, like who knows about the Jeep Cherokee hack? All right, so
What's a Jeep?
I think like 4 or 5 years ago, 2 researchers hacked a vehicle and demonstrated, hey, you can really hack into a car remotely. Was a research thing, nothing ever happened. In fact, no car that's on the road was ever hacked with any negative impact to the passengers. And over the last 5 years, I saw a huge improvement in security. So I would think that, you know, if you take a modern vehicle architecture, a new model that's coming to the road now, it's a very different story. It's very tough to compromise. Obviously, it's not impossible, right? So that's why we need to keep going. But if you look at the statistics, no one ever hacked into a car for reasons of, you know, doing something, changing the vehicle's behavior. People hack into cars to steal them. It's a very common thing. You know, every time there's a financial incentive, someone will figure out how to compromise that, you know, if there's a financial gain. But then I have to say, do you spend $1 million to figure out how to steal a $50,000 car? Or do you spend $1 million to figure out how to hack into the Bitcoin exchange to steal $50 million, right? So, you know, don't forget, automotive is not the only thing in the world. There are other industries where you can get much, much more money. So, yes, of course, we need to become increasingly secure, but there's no need to panic around the topic.
So I'll be the panicker here. So I think André is spot on. However, there's a spin. The difference between attacking a Bitcoin and attacking a vehicle is, to your point, the loved ones. Lives are at stake. You hack my Bitcoin, I'm out of money. You hack my car, or more importantly, a fleet of vehicles, lives are at risk. So we have to up-level the discussion around the value proposition of security on vehicles. I think, if you're from a financial background, banks have been doing this for 100, 200, 300 years. They get it. The auto industry is kind of coming to terms, to André's point, of that the vehicles are not only more connected, but more intelligent, more compute, data center on wheels, 19-inch rack on wheels. But the outcome of being ineffective there is radically different. Lives are at stake, right? So that's really kind of the pivot difference. And again, most boards get it, most leaders get it. It's just a matter of us as a industry getting it, and I'm not sure we're quite there yet.
I think, André, that the only word that is missing in what you said is yet. Now, the financial incentive is there, because just imagine if someone just hack a UPS or a DHL vehicle and send a ransomware demand. And you know, I think that was a couple of weeks ago, a company that was specialized in ransom told the market that they ceased to do their criminal thing because they gained $2.5 billion, and that's enough for them. So the money incentive is there, but there's more than that. First, the fleets can harm the economy if those I don't know, those trucks and all those fleets are stopping from their activity. Now, there's another thing, okay, where everybody's talking in the industry about EV charging, okay? Now, just try to imagine if you're hacking a vehicle and through the charger, you're inside the grid. Then what? Another black night at California?
If you're getting into
this
the
is very
traffic
cheery,
light
this
grids,
one.
what's going to happen while you are through the cars getting into the city grid and start changing all the traffic lights, or if you want to harm someone, or if you want to affect something to happen in the city?
This raises a broader question. When you're into the grid, when you mentioned before about some of the other aspects, and Kevin was talking about financial situation, where do you think the automotive industry is in terms of protecting its vulnerabilities? Is it an industrial leader? Can it learn from other sectors? Moshe, your background's in defense and aerospace. Can we learn something from those sectors?
Well, the answer is absolutely yes. But look at the automotive industry. How many things came from defense aviation? For example, ABS came from defense aviation. Seatbelts, HUD, and the cockpit. The glass cockpit is already there. So now the industry is starting to look at a glass cockpit or those kind of cockpit of the future projects. So lessons learned that are coming from different industries are essential to the automotive. And I think that instead of learning from your own mistakes, you can learn from others, and that saves time, and time is money.
Yeah, it is changing already. It's changing slowly. If you look at the top 10 OEMs and tier ones, and it's already evolving. Look at the leadership, look at some of the lead technologists. They're coming from non-auto industries specifically for that reason, to learn. Yes, we can learn from fintech, we can learn from aerospace, we can learn from even some government organizations. We can all learn. And that's happening, but it's slow. I think the thing that's kind of missing is what's the end goal? And again, I think André kind of touched on it. Are we looking for perfection? Can't say yes and you can't say no, but we're looking for a really good, strong, and vibrant security ecosystem that will support not just auto, but vehicles in general.
So I would like to add one area that I think is still often overseen as manufacturing, right? So the suppliers have huge assembly plants, and there's a real concern that someone hacks into the assembly lines, whether it's denial of service, ransomware, manipulating the firmware that's injected into our components. And I think there's a huge opportunity to learn from other industries, right? Manufacturing is not particular about automotive. Many other industries do that too. And I personally feel that that's, at least for me, that's one of the main concerns around automotive security that's still often overseen.
Yeah. Kevin, you raised an interesting point. I'm going to pass this question first to Hila. The role of government in this. What is the role? Clearly governments want to facilitate the introduction of some of these technologies, some of these vehicles. As we said before, it does open up vulnerabilities. In the UK, we're working with MI5 to try and improve. Incidentally, for those who don't know, the UK security system, James Bond was MI6. That was external. MI5 is domestic. We're working with MI5 to try and improve some of the company's awareness of these issues. Hila, what role do you see for government, indeed, other people?
I think that the country should should be the enabler to understand the risk that we've got and what we would like you to check and to be secure for. And in this point, what we're trying to do now to get ready, we are evaluating like a test center, a cybersecurity test center, that we understand that we will not have the standards in the next few years. We will not have a standard. We cannot have a obvious certificate of what is safe and what is not, but we can evaluate together with the industry a place to facilitate security checks accordingly to this time, at what hacks we know that we have and what risk we have today, and we can ask what we're interested in to go there and to check itself to see that it's secure enough, updated to today, and we're doing it together with industry and with the private sector, because we think we have to work together on it.
I think that there is two drivers. One is the brand protection, and the second one is our customers. But the regulation has one single goal, that we will have a safety for our customers, and this is the key drivers. Now, if we will have a look on the UNEC, the WP 29, this package introduced to the market 5 stages of detection, taking action, giving clear evidence for homologation, what was really running on the ECU, what was the results and impact, and how they took action about it. And these key drivers already been introduced, especially to Europe, Japan, and we can see it in India and China as well. And they're already started to call to OEMs, come and give us your thoughts in regards to these topics. So I see that there is now a window that we need to take care of these requirements in the next 4 or 5 years. So in the next car models where we are going to have major change, it will be first time to introduce these kind of topics.
Yeah, I think we have to be careful what we ask for. So when you ask for, government support, you may get it. So there's just 2 aspects of that. One is regulatory, and one is what I look at from the cyber perspective is intelligence. The regulatory, let's be careful, because some countries, like Israel, for example, may be phenomenally engaged and get it. Some countries just aren't there yet, so they will use a very ham-fisted approach to regulation because that's all they have. The law is a tool, and that's all they have. So we have to be very careful there. I would actually, having been on UN committees, I think the UN may be the best kind of harmonizer there for cyber regulation. The intelligence is where we really need help. There are some countries we work with. We do from the outside. MI6 has been very good. BSI has been very good. In America, we have work to be done. Some of the agencies are extremely outreaching. Some are much less. So if you look across the globe, from an intelligence perspective, especially if there's a committed campaign, we want to know about it. So we want to know specifically what should we be concerned about, where we can actually shore up. So again, I think from the government perspective, again, those 2 aspects, be careful what you ask for, but on the other side, we definitely need more help on what I call sensible regulation, and then, of course, on the threat intelligence side.
Yeah, so I would like to add to that. So globally and in the US, I think there are 2 approaches that provide a better return of the investment, so to say. The first one is the ISO standard 21434, which really, those of you who know what ISO 26262 is for functional safety, the ISO 21434 does the same for cybersecurity. It provides a framework how to develop a vehicle in a secure manner. It's currently specified. It's a global approach. There's more than 100 security experts from all stakeholders in the space. The first draft is internally available. Draft will be published, I believe, in September or October of this year, and I think that will provide a lot of certainty.
But you raise a good point. Are standards a good thing? Because if everyone is manufacturing to a standard, does that mean once you find a vulnerability in it, you've got open access to every single.
And so, sorry to go again, so that's my second point, and that's an American thing. There's the Auto ISAC. They try to be global. Currently, it's still very American-focused. ISAC for Information Sharing and Analysis Center, where basically all global car makers and suppliers came together and exchanged information. There's a vulnerability becoming known, you know, and this happens already. A car maker sees, oh, there's something really funny happening to one of our systems. They will share this information with the other members of the Auto ISAC so that everyone is enabled to react before something happens. And I find that's the much more efficient approaches than regulation.
Kevin, to your point, the 2 point of views of regulators, as a driver, I would like regulations like the FAA. As an industry participant,
as a pilot, I don't.
No, as a company that take a role in this industry, I want to keep on using the self-regulations, but with standards, as André has mentioned. And if you're looking at different industry, Auto ISAC came from the idea that was running in the aerospace industry. So the sharing and the common knowledge and the fact that we are all have a goal that our customers eventually are going to drive safe vehicles, that's a common goal for everyone. If that being kept, then we're all on the same page.
Just on that, I mean, it's a consumer-driven industry. Consumers listening to this debate will probably be more worried than when they walked into this room. So how can you go about assuring the consumer that their vehicle, their journey is safe? Zohar?
If I may. So most of the breaks is going to be through lines of code, the software itself that executes on the vehicle. So the risk is there, and we cannot close the system. This is very simple. We cannot have a 100% system. Now the question is, once we detect these kind of problems, how can we recover from it very, very quickly in a way that the users will not know about it? How can we maybe self-heal the malfunctioning problem? How can we kill, delete processes, roll back to a safe point, etc.? Maybe doing the kind of silent recall so nobody will know about it. So I think that this is part of the topics that we need to develop in our discussions in cybersecurity, not only about to prevent it. Once we detect it, what are the actions that we are going to take here?
Yeah, I think specifically to your question about safety, we're safe. I'm going to be really, really clear. As a long-term practitioner in cybersecurity, generally speaking, vehicles are safe. However, you hit on something that's really, really important, and that is the opaqueness. It's not that we want to hide anything, but it should not necessarily have to rise to the top level of your local newspaper that, you know, a ransomware attack is permeating through, you know, some system. It's irrelevant. We need to self-heal, to your point. Now, I think that one of the things that is concerning is that as an industry, we're not all on the same page. We have some that get it, have been very, very strident, very resource intense to address cyber. Others who are just learning. So you have this disconnect in the industry. And that will collapse. It'll collapse in one of two ways, either because of an event, and they will be neutralized, essentially. Let's be honest. Companies go out of business for a reason. And I think we just have to be careful as practitioners and in the industry and as regulators that we all want the same outcome, that's safe driving. I do not fear my family getting into an autonomous vehicle. No asterisk.
We're nearly out of time, so I'm going to ask one last question, which is intentionally a provocative one. And it picks up the point that Moshe made earlier, that the safest car was the Model T. As we move towards connected vehicles, autonomous vehicles, is the risk worth it?
Would you go to the telephone that Alexander Graham Bell invented? Probably not. And guys can hack your phone, steal your data, and penetrate your bank account and do all of those things. We are evolving, we are in a different era. So I think the risk is worth it, okay? Nobody wants to drive a Model T. First, it's cost a lot of money, but still, I think the user experience and the fact that we are moving, and you know, when autonomous vehicles will be all over, maybe we'll have less car accidents. That if you imagine, that's a Boeing 787 per week in America.
Yeah. So again, keep this in context. It wasn't that long ago that we didn't have seatbelts and we didn't have airbags. So, and people at the time fought that, right? Without reason. But let's be honest, going to an era where we have autonomous vehicles, that's all vehicles, not just passenger cars, is inevitable, it's prudent, it's green, and it's the right way to go. Our responsibility is to make sure that we can affect that change positively.
I can't think of a better way to end it, because we're bang on time, and in the automotive industry we do work on time, just in time. So, ladies and gentlemen, thanks so much for your attention. Please give a round of applause to your panel.